Hello everyone, this is Anon from AnonMath channel. In this video, we're going to take a look at 5 quadratic equations, and we're going to solve them by completing the square using 5 simple steps. By using these 5 steps, you can solve any quadratic equation by completing the square, and in this video, we're going to solve 5 of them, so make sure to watch the whole video, because I'm going to solve quadratic equations with complex solutions, with complex coefficients, and with radical coefficients. So don't miss the rest of this video, and after watching this video, don't forget to click like if you enjoyed watching it, and click subscribe for more content. Now, first of all, let's take a look at the 5 simple steps that we're going to use to solve a quadratic equation by completing the square. The first step is to divide everything by the leading coefficient. The second step is to move the constant term to the right-hand side. And the third step is to add a special number to both sides. And the fourth one is to rewrite the left-hand side as a perfect square. And the last one is to solve the equation using reverse operations. Great. Now, let's go ahead and take a look at the first equation and use these 5 steps to solve the equation by completing the square. The first equation is negative x squared plus 4x plus 165 equals 0. So the first step is to divide everything by the leading coefficient. The leading coefficient is the coefficient of x squared, which means that, in this case, the leading coefficient is negative 1. So we need to divide everything by negative 1. So if we do that, we get x squared minus 4x minus 165 equals 0. Then, in the second step, we need to move the constant term to the right-hand side. In this case, the constant term is negative 165, so we need to add 165 to both sides. So we should get x squared minus 4x equals 165. In the third step, we need to add a special number to both sides. We can always find the special number by taking the middle coefficient, the coefficient of x, in this case negative 4, and then dividing it by 2, and then squaring it. So negative 4 divided by 2 is going to equal negative 2, and negative 2 squared is going to be 4. So we need to add 4 to both sides. So we have x squared minus 4x plus 4 equals 165 plus 4, which is 169. Now, the fourth step is to rewrite the left-hand side as a perfect square. It is obvious that the left-hand side is x minus 2 quantity squared, and on the right-hand side we have 169. And the last step is to use reverse operations to solve this for x. So first we need to take the square root of both sides, and then if we do that, we get x minus 2 equals the square root of 169, which is 13. And notice that when we take the square root of a number, we have 2 possible values, positive or negative. So x minus 2 equals positive or negative 13. And that means that if we add 2 to both sides, we get x equals 2 plus or minus 13, which means x is either 2 plus 13, which is 15, or x is 2 minus 13, which is negative 11. So we found out 2 solutions for this quadratic equation by completing the square. Now let's go ahead and take a look at the second equation in which the leading coefficient is neither 1 nor negative 1. The second quadratic equation we're going to solve by completing the square is 3x squared minus 11x plus 10 equals 0. So again, the first step is to divide everything by the leading coefficient. The leading coefficient here is 3, so we need to divide everything by 3. And if we do that, we should get x squared minus 11 thirds times x plus 10 thirds equals 0. And then in the second step, we need to move the constant term to the right-hand side. So we need to move 10 thirds to the right-hand side. And if we do that, we get x squared minus 11 over 3 times x equals negative 10 divided by 3. And again, in the third step, we need to add a special number to both sides. And we can find that special number by taking the middle coefficient, negative 11 over 3, and then dividing it by 2, and then squaring it, which gives us negative 11 over 6 quantity squared, which gives us 121 over 36. So we need to add 121 over 36 to both sides. And then in the next step, we need to rewrite the left-hand side as a perfect square. So we will have x minus 11 over 6 quantity squared. Now you might ask, why 11 over 6? Because 121 over 36 is the same thing as 11 over 6 quantity squared. And you might ask, why x minus 11 over 6? Why we didn't have x plus 11 over 6? Because the middle coefficient is negative. And when the middle coefficient is negative, we will have x minus some number. But if the middle coefficient is positive, then we will have x plus some number. So in this case, the middle coefficient is negative, and the third number is 11 over 6 quantity squared. So we will have x minus 11 over 6 quantity squared. So this equals negative 10 over 3 plus 121 over 36. And then we can get a common denominator for the right-hand side. We need to multiply the first fraction, both the top and the bottom of the first fraction, by 12. So we get negative 120 plus 121 divided by 36, which is the same thing as 1 over 6 quantity squared. And then the last step is to solve for x using reverse operations. We need to take the square root of both sides. So if we do that, we get x minus 11 over 6 equals positive or negative 1 over 6. So that means that x is 11 divided by 6 plus or minus 1 over 6. And that means that x is either 2 or x is 10 over 6, which simplifies to 5/3. So again, we use the completing square strategy using these 5 steps, and we solved for x. Now let's go ahead and take a look at the third example that has complex solutions. The third one is 5x squared plus 6x plus 5 equals 0. Again, we're going to first divide everything by 5, the leading coefficient. So we get x squared plus 6 over 5 times x plus 1 equals 0. And then we're going to subtract 1 for both sides to move the constant term to the right-hand side. So we get x squared plus 6 over 5 times x equals negative 1. And then we need to add a special number to both sides. The special number is 6 over 5 divided by 2 and then squared, which gives us 3 over 5 quantity squared, which gives us 9 over 25. So we need to add 9 over 25 to both sides. So on the right-hand side, we have a perfect square, and we can rewrite it as x plus 3 over 5 quantity squared. Now again, since the middle coefficient is positive, we have x plus some number. And since 9 over 25 is 3 over 5 squared, so we have x plus 3 over 5 quantity squared. And on the right-hand side, we have negative 1 plus 9 over 25, which is the same thing as negative 25 plus 9 over 25, which is negative 16 over 25, which is the same thing as negative 1 times 16 over 25. And negative 1 is the same thing as I squared, and 16 is the same thing as 4 squared, and 25 is the same thing as 5 squared. So we can rewrite the whole thing as 4 times I divided by 5 quantity squared. So on the right-hand side, we have 4i divided by 5 quantity squared, and on the left-hand side, we have x plus 3 divided by 5 quantity squared. So we can take the square root of both sides, and if we do that, we get x plus 3 over 5 equals positive or negative 4i divided by 5. And then this gives us x equals negative 3 over 5 plus or minus 4i divided by 5. So x is either 4i minus 3 divided by 5 or x is negative 4i minus 3 divided by 5. So as you can see, we found two complex solutions for this quadratic equation using completing the square strategy. Now, let's go ahead and take a look at the fourth one, in which we're going to have radical coefficients. And it's going to be super interesting. I guess it's going to be the most interesting one. So we have 2x squared plus root 8 times x minus 3 minus 2 root 3 equals 0. So first we need to divide everything by 2, the leading coefficient. So we get x squared plus root 8 divided by 2 times x plus negative 3 minus 2 root 3 divided by 2 equals 0. And then we need to move the constant term to the right-hand side. So we have x squared plus root 8 divided by 2 times x equals positive 3 plus 2 root 3 divided by 2. Now notice that square root of 8 is the same thing as 2 root 2. So this is going to be 2 root 2 divided by 2, which is root 2. So the coefficient of x is root 2. So in order to find the special number that we're supposed to add to both sides, we need to take the square root of 2 and then divide it by 2 and then square it. So we should get 1 over 2. So we need to add 1 over 2 to both sides. And then we need to rewrite the left-hand side as a perfect square. So it's going to be x plus root 2 divided by 2 quantity squared equals 4 plus 2 root 3 divided by 2. Now we can reduce this fraction, but I'm not going to do that, and there's a reason for that. 4 plus 2 root 3 is a special number because it is the same thing as 1 plus 2 root 3 times 1 plus 3. So we can rewrite 1 as 1 squared, and we have 2 root 3 times 1, and we have 3, which is the same thing as root 3 squared. So basically, this number is in the form of a squared plus 2ab plus b squared. So this is a perfect square, and we can rewrite it as 1 plus root 3 quantity squared. And we can rewrite 2 as root 2 squared. So this is going to equal 1 plus root 3 divided by root 2 quantity squared. And if we rationalize the denominator, we're going to have root 2 plus root 6 divided by 2 quantity squared. I just multiplied both the top and the bottom of this fraction by root 2. So in order to solve this for x, we need to take the square root of both sides. If we do that, we get x plus root 2 divided by 2 equals positive or negative the quantity root 2 plus root 6 divided by 2, which then gives us x equals root 6 divided by 2, or x equals negative 2 root 2 minus root 6 divided by 2. So these are two solutions for this interesting quadratic equation, and we found them by completing the square. Great. Now let's go ahead and take a look at the last quadratic equation, in which the coefficient of x is going to be negative I. So the last one is 6x squared minus ix plus 2 equals 0. Again, we're going to use these 5 steps to complete the square and solve for x. So first of all, we need to divide everything by 6. And if we do that, we get x squared minus I over 6 times x plus 2 over 6 equals 0. And then we need to subtract 2 over 6 from both sides to move the constant term to the right-hand side. So we get x squared minus I over 6 times x equals negative 2 over 6. And then we need to take this number, negative I over 6, and then divide it by 2, and then square it to find our special number. So this equals I over 12 quantity squared, which is the same thing as negative 1 over 144. So we need to add negative 1 over 144 to both sides. And then we need to rewrite the left-hand side as a perfect square, which gives us x minus I over 12 quantity squared. Again, since the middle coefficient is negative, so we have x minus I over 12. And since negative 1 over 144 is the same thing as I over 12 quantity squared, so we have x minus I over 12 quantity squared. And on the right-hand side, we will have 144 as the common denominator. We need to multiply both the top and the bottom of the first fraction by 24. So on the top, we will have negative 48 minus 1, which gives us negative 49 divided by 144, which is the same thing as negative 1 times 49 divided by 144, which is the same thing as I squared times 7 squared divided by 12 squared, which gives us 7i divided by 12 quantity squared. And then if we take the square root of both sides, we get x minus I over 12 equals positive or negative 7i divided by 12. So this gives us x equals I over 12 plus or minus 7i over 12, which means that x is either 8i divided by 12, which is the same thing as 2i over 3, or x is negative 6i over 12, which reduces to negative I over 2. So again, in the last one, we used these 5 steps, and we completed the square, and we solved for x, and we found 2 complex solutions for this interesting quadratic equation, which had negative I as the coefficient of x. And this brings us to the end of this video. As I told you before, if you enjoyed watching this video, click like, and for more content, click subscribe, and don't forget to leave a comment. Goodbye, and I will see you later in another video.